Okay, you're ready to work on your Chapter 2 review, and it's going to involve, or what I have assigned, is the odd problems on 3 through 60. This will probably pretty much start to wrap up the items for you. So the review is going to be over limits, and it will also be off of the different derivatives that you are going to have that we talked about, whether it be the exponent rule, the product rule, the quotient rule, the chain rule. So it's just going to be various ones that we talked about. All right, so if we look at the first one here, this is problem number 4, so this is not one you have to do, but it just gives you a refresher of some limits. So if I have the limit as x approaches 3 of 3x minus 1, remember what the limit means is it's the value you are going to approach, and you get closer and closer to until you hug each other. It's that point P and Q that create that secant line, and as P moves closer to Q, what is that value that they approach? So we're going to go ahead and calculate this. So in order to calculate it, you're just going to take what x approaches and you're going to put it into your expression. So it's going to be equal to 3 times x, which we're going to say as it approaches 3, minus 1, and if you calculate that, you're going to get an answer of 8. So that's all they are looking for, is just what is that value be as you approach it. Not what is it right at that point, but what does it approach as you come from both the positive and the negative side. Okay, another thing that can happen, this happens to be problem number 10. Now remember, you're just supposed to do the odd problems. So it is very similar to number 9 and then follows through with the rest of the problems. So what you want to do is the same thing you did before. You substitute the value in. So you're going to get 3 times negative 3 plus 9 divided by negative 3 squared plus 3 times negative 3. So when you calculate that, you're going to end up with negative 9 plus 9 over 9 minus 9. And you end up with 0 over 0. So what I wanted to do was refresh your memory. When you get 0 over 0, when you were dealing with limits, remember what you have to do is you have to go through and factor the original problem. If you had 5 over 0 or any other non-zero number, if you had a non-zero number divided by 0, then it would be does not exist. But since you have 0 over 0, we have to go through and factor. So we're going to take the limit. Remember, these problems were the ones you have to always write the limit until you substitute in the value. So you take the limit as x approaches 3, and if I numerator, when you factor the numerator, you can factor out a 3, which leaves you with x plus 3. In the denominator, you can factor out an x, which leaves you with x plus 3. Then you're going to notice that the x plus 3's cancel. So you write it again. It is the limit as x approaches negative 3. And if I reduce that, you get 3 over x. Now you don't have to write limit because you're ready to just substitute it in. And the answer you are going to end up with is negative 1. So the limit as x approaches negative 3 for this particular problem or expression ends up being negative 1. So as point P and Q get closer and closer and closer together, you're going to approach a y value of negative 1. Okay, here's another example, and it probably lines up more with problem number 13, but this is problem number 14, but it's going to be similar to those types of problems. You substitute the value in. So if I substitute that value in, you're going to get, I'm trying to write without my hand being in the room, 4 minus 4 raised to the 3rd over, you're going to take 4 squared minus 4 minus 12. So if you calculate, you get 0 cubed over 16 minus 4 minus 12. And once again, you get 0 over 0. So what we want to do is we want to go ahead and factor. So if we look at the numerator, remember you got to write the limit again. So it is the limit as x approaches 4. And the numerator is factored, so we have the quantity x minus 4 cubed. The denominator factors into the quantity x minus 4 times the quantity x plus 3. Remember, you look here, the signs are different. Factors of 12, outer and inner need to give you -1. So when you look at this particular problem, we will notice that x minus 4s is going to cancel, which will leave you with 2 of them in the numerator. So we'll write the limit again. So it is the limit as x approaches 4 of the quantity x minus 4 squared over x plus 3. So now I want to substitute back in, and you're going to get 4 minus 4, quantity squared, over 4 plus 3. So you end up with 0 over 7. Now that's okay, because we remember that 0 divided by 7, that is okay, and your answer ends up being 0. Okay, so the next thing I want to talk about is the derivatives that you will need to be doing. So as we look at the derivatives, one for an example, remember if this happens to be f of x, and I should have put that in front. If this is f of x and they want you to find f prime of x, which means the derivative. Remember, derivatives means that what you are finding the slope of the tangent line to the curve at any point on x. So if they ask you to find the derivative of this, the first thing you would want to do is you would just want to take x and you would want to rewrite this. So f of x, I would take that square root or the cube root of x squared, the cube root of x squared, and I would write that as x. Remember, you have the power, which is 2, and the root, which is 3. So the cube root of x squared means the same thing as x to the 2/3 power. Now we can still simplify that, and I recommend always go through and writing f of x or f prime of x so you know what you're finding. If I group those x's together, when you multiply like bases, you add exponents. So f of x is the same thing as 6x to the 5/3 power. So after I have f of x, then I can go ahead and take the derivative, and the derivative of this is just going to be the simple power rule. So I need to take 6 times 5/3. Normally I probably would not show that right there, but then I'm going to decrease it by 1, which is going to be 3 over 3, which means that, and some of you are going to use your calculator, the derivative, or f prime of x, is equal to 10x to the 2/3 power. So remember the power rule when you are finding the derivative. Okay, another example using the rules for differentiation. If I tell you f of x is equal to plus 1 to the 3rd power, we want to do the power rule again, so I'm going to find the first derivative, which is all they want. So to find the derivative, I'm going to bring down the exponent, keep what's inside the parentheses the same, decrease the exponent by 1, but the thing you don't want to forget is you have to multiply by the derivative of what's inside. So the derivative of 3x is 3, and the derivative of 1 is nothing. So you just end up with 3. Now as a final step, I would go ahead and multiply at least the whole numbers together. So 3 times 3, I would show it as 9, times the quantity 3x plus 1 squared. And that's going to be your derivative, the first derivative. Just another example of a problem you might encounter looks like this, the square root of that quadratic. So once again, the first thing you want to do is rewrite that quadratic. Instead of the square root, let's put it in a form that's usable. So we're going to show it as x squared plus 8x minus 10. And the square root means to the 1/2 power. So now we can continue with the derivative. So when you take the derivative, you bring down the exponent, keep what's inside the parentheses the same, decrease the exponent by 1, which is negative 1/2, and then don't forget to take the derivative of what's inside, which is going to be 2x plus 8. Now sometimes if you want to, you could probably for this particular problem, but you could take that 1/2 and distribute it through that binomial. 1/2 times 2x is just x, and 1/2 times 8 is 4. And then you have x squared plus 8x minus 10 to the negative 1/2 power. So that's another way that you could write it. I told you before that is professor dependent, so go to class and see which way your professor prefers it.